Okay, so let's go ahead and work this Bernoulli's principle problem. And in this problem, we have we're told that there are 100 mile an hour winds, 45 meter per second winds going across the top of the house, and we want to calculate the force on this house due to this Bernoulli effect that we're talking about. So there's going to be some pressure inside the house. Okay? And that pressure inside the house is going to push upward on the roof of this house. And then there's going to be some sort of pressure outside. Okay? Now, the force, the upward force on the roof, okay, the upward force on the roof is going to be the pressure inside. So remember, force is pressure times area. So it'll be pressure inside times the area of the roof. That would be the upward force. But then there's a downward force pushing down. So the total upward force would be the inside upward force minus the downward outside force. And the downward outside force is going to be the pressure outside times the area. So therefore, this is equal to the pressure difference, pressure in minus pressure out, times the area of the roof. Okay? So we need to find the pressure difference between inside and outside. And to do that, we're going to use Bernoulli's principle. And remember, Bernoulli's principle says that the pressure plus 1/2 density times velocity squared in one part of the fluid flow is equal to the same in another part of the fluid flow. So what that means is that the pressure inside plus 1/2 density inside velocity squared equals pressure outside plus 1/2 density times V outside squared. And remember, you can apply Bernoulli's principle whenever your fluid basically is at the same height. And that might look like that's not the case for this house here. But what we're going to do is consider 2 points. One point, our outside point, is just above the roof, and our inside point is just below the roof. So those 2 points are at approximately the same height. And so then we can therefore apply Bernoulli's equation in this form. Okay? All right, so what's our inside velocity? Well, it's 0. Okay? So that term goes away. So if we want to know what is the difference in pressure between inside and outside, okay, that's what we need up here to calculate the force. Well, that's therefore, we subtract pressure out from both sides. It's 1/2 density of air times that outside velocity squared. So therefore, the upward force on the roof, okay, is going to be pressure inside minus pressure outside, which is the 1/2 rho, and I'm going to drop this out part now and just call it V squared, times the area of the roof. Okay, so there's our expression. We can start plugging in this information now. And so this is 1/2. The density of air, we're told, at the elevation of, Colorado is 1.14. Okay. The velocity, we're told, is 45 meters per second, and I'm just dropping the units here. And that's fine, just as long as we make sure we have all our units straight. This is kilograms per cubic meter, meters per second, and this has to be squared, remember, times the area of the roof, which we're told is 220 square meters, so that's also in the correct units. So we do this multiplication here, we do that operation, and what you get is a pretty big number. It's 254,000 newtons. Okay? And in terms of pounds, that's about 60,000 pounds. So that's way larger than the actual weight of the roof. So, if you have a 100 mile an hour wind like this, you better have a pretty stable structure, something that can withstand your roof literally being blown upward with a force of 60,000 pounds. So you might think in very high wind conditions like this, it's the force of the wind itself, just it's blowing, catching the roof, and literally peeling it off. But that's not the case. It's really the pressure inside the house that's blowing the roof off in these types of conditions. Now this is a really extreme example, and this situation is true really only if that wind is literally going parallel to the roof and exactly going level to the roof like that. But what really tends to happen on windy days is you have turbulence and all kinds of things going on here, and turbulence really tends to diminish this effect here. So, really in practice it's significantly less than this, but still can be significant enough in a lot of cases to literally blow the roof off your house. Not so much, ripping the roof off the house. It's literally the pressure inside the house blowing the roof upward.